Okay, this chapter that we're starting, Unit 9, is all about right triangle trig. So it's a lot of definitions. Right triangle trig is basically working with the ratios of the sides of a right triangle. So when we're trying to figure out what the sides are, there are specific labels that we're going to use to define our trig functions. So to begin with, we're going to talk about this symbol right here. This is the symbol theta. It's a Greek letter. And a lot of times we just use theta to represent an angle, any angle. You could represent an angle with a capital letter. You could put a capital letter on the outside here. We could label it with another variable. We could call it x. We could label it anyway, however we want, pretty much. But we have to know what angle we're working from. So when we figure out how we're labeling it, so we're just going to stick with theta on this one. Hypotenuse in a right triangle is always the side across from the right angle. So here's my right angle. It's always the longest side in your triangle. 90 degrees is the biggest angle, so it has to be across from the longest side. That's always called your hypotenuse. Now, the two other words that we're going to use to define our right triangle trig functions are the words adjacent and opposite. So what I like to do is pretend that you're standing in a triangle field and you're kind of in the corner of a triangular field. And if you could reach out and touch each side, so I could touch this side over here and I could touch this side over here. One side's called the hypotenuse. The other side that I could touch is what we're going to call adjacent. It's right next to me. I can reach out and touch it. That's the adjacent side. So then that means if I were to walk across the field to get to this side, that's going to be what we're going to call the opposite. It's clear on the other side. It's opposite from us. So these three words are really important. It's really important on how you label them. You can't just randomly choose. So if I move my theta to the top now, so my theta is in a different spot, so theta is right here, well, hypotenuse is always across from the right angle. So this is still my hypotenuse. That doesn't change. All right. We have to figure out which side's the adjacent side and which side's the opposite side. So remember, you're standing in the corner of the field. You can touch the hypotenuse and you can touch the adjacent side. So this side is adjacent. And then you would have to walk across to get to the opposite side. So that's considered the opposite. So what we're going to do now is we're just going to quickly label a bunch of triangles oriented in different ways. And we just want to label them hypotenuse, opposite, and adjacent. So this would be something that you would do in class. You just take a minute to do that. I'm going to quickly label them, and then we're going to move on. Okay, so you can take a minute, see if you labeled them the same way I did. You can check your work to see how you did. We're going to move on now to the definitions. So trig functions always have a name. So they start with the name first. So your name is right here, and I'm going to tell you what these names are here in just a minute. Okay, so we're going to talk about what the names are in a minute. Always followed by an angle. So the next spot that follows after the trig name is an angle. And then it always equals a ratio of two sides. So down here is an example. The trig name that I'm using is sine. I use the theta symbol to represent my angle. And then the ratio of the sides that I was comparing are 4/5. So it's got there's always four parts to it. There's a trig name, an angle, and then two sides. So every time you're using right triangle trig, you've got to have a name, an angle, and two sides that you're comparing. Okay, so let's go ahead and learn the definitions of the 6 trig functions. So the first trig function is called sine, and it's abbreviated SIN, but you still say sine. You don't say sin, you say sine. So sine, and then there's always an angle, so I'm just going to let theta represent that. And then by word definition, the two sides that I'm going to be comparing in my right triangle are the opposite side over the hypotenuse. Okay, the next trig function is called cosine, and it's abbreviated with COS. So I'm just going to write cosine theta. And then the two sides that out of the right triangle that the cosine compares are the adjacent side and the hypotenuse. Okay, and then the next trig function is called tangent. and it's abbreviated TAN, so you would say tangent theta equals, and then the two sides out of the right triangle that it's comparing are the opposite side and the adjacent side. Now, each of those trig functions has a reciprocal. So the reciprocal of the sine is called cosecant, and its abbreviation is CSC. So you'll write cosecant theta equals, and it would be comparing the hypotenuse over the opposite side. And then the reciprocal of the cosine is called the secant, and it's abbreviated SEC, so secant theta, and it would be considered the hypotenuse over the adjacent side. And then the reciprocal of tangent is called cotangent, and it's abbreviated COT, so you would write cotangent theta equals, and then the two sides you'd be comparing is the adjacent side over the opposite side. So in this triangle here on the right, if my theta was down here in the right-hand corner, this would be considered the opposite side. This is my adjacent side, and this is my hypotenuse. So I would be picking two of those three sides every time I wanted to use one of those trig functions. So we'll go ahead and practice that. So here I have a right triangle, and I've actually put in all the side lengths, and it matters where theta is. So in this particular problem, theta is in the bottom right-hand corner. So if theta is in the bottom right-hand corner, then this side is considered the opposite side, the side with the 5. The 12 is considered the adjacent side, and of course the 13 is the hypotenuse. It's across from the right angle, so that's the hypotenuse. Okay, so when I come over here and I do sine theta, remember sine theta word definition is opposite over hypotenuse. So I'm going to look for the opposite side, which is 5, over the hypotenuse, which is 13. So the ratio I'd be looking for would be 5 over 13. Whoops. Okay, cosine, word definition of cosine is the adjacent side over the hypotenuse. So the adjacent side on this particular one is 12. So, and the hypotenuse is 13, so I'd write that as 12 over 13. And tangent theta is comparing the opposite side over the adjacent side. So opposite side is 5, adjacent side is 12. So cosecant theta is the reciprocal, so cosecant theta is the hypotenuse over the opposite. It's the reciprocal of the sine, so that's going to be 13 over 5. Secant is hypotenuse over adjacent. It's the reciprocal of the cosine, so that means it's 13 over 12. And cotangent is the reciprocal of tangent, which means it's adjacent over opposite. And so that's going to be 12 over 5. Okay, so we've had our trig name, we have the angle, and then we have the two sides that we're comparing. Okay, so here we go again. This would be, I would probably let you try this on your own in class. I'm going to take a minute here and I'll just fill all these in, and then we'll pick up again with some more problems. Okay, notice on this one the theta moved up to the top left-hand angle, so that means that the opposite side is now on the bottom and the adjacent side is on the left. So you got to make sure that you know where the adjacent and the opposite side are. It matters. Those two are always switching up. Depending upon where the angle is, those two sides switch. So sine theta, remember, is opposite over hypotenuse. So this is 9 over the square root of 117. Okay, so I'm going to go ahead and rationalize that. So that's going to turn out to be 9 square root of 117 over 117. And then cosine theta is the adjacent side, so that's 6 over the hypotenuse. So that's the square root of 117. Rationalize that, and we get 6 square root of 117 over 117. And then tangent theta is the opposite side 9 over the adjacent side 6. Always reduce your fractions. So not only do you have to rationalize, but you have to reduce. So those both reduce by 3, so you end up with 3 over 2. Okay, now I'm going to go do the reciprocal functions. When I do the reciprocal functions, though, I'm going to do the reciprocal of here. I can pull it off my triangle, but I usually just look over here and see what the sign is. I'm not going to do the reciprocal of the end problem because then that would put, or the end answer, because that would put a square root in the bottom. So I'm actually going to go one back and do the one where the square root was in the bottom, because when I do the reciprocal, it'll turn out to be in the numerator. So this will turn out to be the square root of 117 over 9. I'll do the same thing with secant theta. It's the reciprocal, and so it's going to be the square root of 117 over 6. But this time with cotangent, I'm actually going to use the last one that I did because it was the reduced one. So I'm going to do the reciprocal of 3 over 2, and that's going to turn out to be 2 over 3. Okay, so hopefully we're starting to get these definitions. There is an acronym to help you remember. It's called SOHCAHTOA. So it's SO, S-O-H, ka, kind of like a bird. So C-A-H, and then TOA, T-O-A. So that helps you remember all, because you're going to have all 6 trig functions memorized. It helps you remember sine, cosine, and tangent, and then you just have to remember which ones are the reciprocals of what. So right here, the S stands for sine. The O stands for opposite. H stands for hypotenuse. C stands for cosine. A stands for adjacent. H for hypotenuse. T stands for tangent. O for opposite. A for adjacent. So SOHCAHTOA can help you remember sine, cosine, and tangent. You have to have those memorized. All right, so now we're supposed to do all 6 trig functions. I'm looking at this triangle, though, and I need to have all my sides. I know this side, the adjacent side, is 4, and I know the hypotenuse is 5. I'm missing the opposite side. Well, it's a right triangle. Pythagorean theorem to find your missing side, or hopefully you recognize that this is a 3, 4, 5 triangle. It's a Pythagorean triple. So once you've done that, once you've found your missing side, then you can go ahead and write all your trig functions. So sine theta is opposite over hypotenuse. Cosine theta is adjacent side over hypotenuse. Tangent theta is opposite side over adjacent side. Cosecant theta is the reciprocal of sine, so it's 5 over 3. Secant theta is the reciprocal of cosine, so it's 5 over 4. And cotangent theta is the reciprocal of tangent theta, so that answer is 4 over 3. Okay, same thing again. Hopefully we're getting these trig functions memorized. So this time, though, I'm telling you that cosine theta equals 8 over 13. Well, I know that this deals with ratios of a right triangle, so I think I'm just going to go ahead and draw a right triangle. Doesn't matter how you draw it. And it doesn't even matter where you put theta. It matters after you put theta what you do next. So I think I'll put theta here, the bottom right-hand corner. Word definition of cosine is it's the adjacent over the hypotenuse. So if my theta is in bottom right-hand corner, that means this side is the adjacent side, this is the opposite side, and this one is the hypotenuse. All right, so that means this side right here, my hypotenuse has a value of 13. My adjacent side has a value of 8. I'm going to do the Pythagorean theorem to find the missing side. So I'll just call this side right here for a minute. I'll just call it A. So A squared plus 8 squared equals 13 squared. So A turns out to be 13 squared minus 8 squared. Take the square root of that. And what do we end up with? Let's see. 13 squared minus 8 squared. Okay, so let's just do square 105. So square root of 105. So square root of 105. Okay, so now we're going to go ahead and do all of our 6 trig functions. So sine theta is opposite side, which is the square root of 105 over the hypotenuse. Cosine theta is adjacent side over hypotenuse, which that was already given to us. Tangent theta is opposite side over adjacent side. And then cosecant theta is the reciprocal of sine theta. So that's 13 over the square root of 105. Rationalize that. So 13 the square root of 105 over 105. And secant is the reciprocal of cosine. So that's 13 over 8. And cotangent is the reciprocal of tangent. So that's going to be 8 over the square root of 105. Rationalize that. And there's our 6 trig functions. Okay, now we're actually going to try to figure out what a missing side would be if I knew actually what theta was or what the given angle is. So in right triangle trig, if you know the angle, there is a certain ratio that the sides make with each other. Doesn't matter how big your triangle is, the sine ratio always reduces down to the same thing for a given angle, and the same thing with the cosine and the tangent. That's what's programmed into your calculator. That's how you can how come you can use your calculator to solve these problems. They all reduce to the same ratio. So to begin with, you're going to need to find your calculator, and so you're going to need to look and find your sine, cosine, and tangent button. So they're going to have, probably going to look something like this. Somewhere on your calculator, you need to look for these 3 buttons. Okay. The other thing that you need to make sure of is this is degree mode right here. That's a degree symbol. So you need to make sure that your calculator is in the correct mode. So somewhere there is a mode button, and just make sure it's highlighted on degree. If you have a little scientific calculator, usually somewhere in the screen it'll say DEG, then you'll know it's in degrees. The graphing calculators, you have to hit the mode button and make sure you're highlighted on degrees to make sure you're in the correct mode. We will be learning about what radians are in another lesson, and so there's more than one way to measure an angle. It's not just degrees. Degrees is all you guys know, but there are other ways to measure an angle. So once you've got that figured out, where those buttons are on your calculator, you've got to figure out which button to use. So to do that, you've got to know which trig ratio to use. Now, since you only have sine, cosine, and tangent on your calculator, those were the trig ratios I would choose. I wouldn't choose secant, cosecant, or cotangent because those buttons aren't on my calculator. So to begin with, you're going to start here at this angle, 47 degrees. That's like your theta. So you've got to figure out what the sides are that are labeled. So if 47 degrees is my theta, then x must be my hypotenuse, and 6 must be considered the adjacent side. So out of sine, cosine, and theta, or excuse me, tangent theta, which one of those 3 trig functions has a definition that uses adjacent and hypotenuse? Well, it's the cosine. Cosine is adjacent over hypotenuse. So that's the trig function I want to use to solve this. It's a very specific one. It's not random. I have to use cosine. So to write this out, we're actually going to put in the numbers everywhere the definition is. So we're going to say cosine of 47 degrees equals the adjacent side, which is 6, over the hypotenuse, which is x. And now we're going to solve that for x. So to do that, I think I'm going to multiply both sides by x. That will give me x times the cosine of 47 degrees equal to 6. Then I'm going to divide by this whole thing. This is kind of one term. You got to divide by the cosine of 47 degrees. So x equals 6 divided by the cosine of 47 degrees. So this is where I would go to my calculator and I would type in 6, divide, and then I would hit the cosine button, and then 47 behind it. So for 47 degrees. and you end up with 8.79. So we'll say this is about 8.8. So this missing length right here is about 8.8. Okay, so let's try it again over here on the right. So once again, I'm going to use this angle as my theta. Now, I could use this angle up here. I know what it is. 68 is complementary to this angle right here. Remember, inside a triangle is 180. I already know this is 90. So that must mean then these two have to add up to 90 themselves. So if one of them is 68, then the other one is probably 22, because 68 plus 22 is 90. Those two are complementary. The two acute angles are complementary. Okay, well, I think I'll just stick with the given information. I'm going to use this as my theta right here. So I'm going to use 68 as theta. So I've got to figure out what are my labels for my side. So if I'm standing at 68, then the x is considered the opposite side, and the 18 is considered the hypotenuse. So once again, you have to pick the right trig function. Do I want sine theta equals opposite over hypotenuse? Do I want cosine theta equals adjacent over hypotenuse? Or do I want tangent theta equals opposite over adjacent? Well, I go and see what the information is that's given. It looks like to me I have an opposite side and a hypotenuse. So out of those three trig functions, the only one that has an opposite side and a hypotenuse is sine theta. So that's the one I'm going to use. So I'll come over here and set it up, and I'll say sine, and instead of writing theta, I'm going to put the actual value of 68 degrees equals the opposite side, which is x, over the hypotenuse. Okay, so I need to solve this for x. So I'm going to multiply both sides by 18. And this time when I multiply both sides by a number, I actually end up with the answer that I'm looking for. I don't have to divide anything. That actually tells me what x is. So now I go to my calculator and I do 18 times the sine of 68. So I hit the sine button and then 68. And it turns out then that the opposite side is about 16.7. So x is about 16.7. Okay, come down here. We got two more to try. So once again, you can use this angle up here at the top of 12 degrees if you wanted. I think I'll just do what's given. I'll use the 78 as my theta. So if this is theta, then this side is opposite, and this is considered, the 7 is considered the adjacent side. So out of our trig functions, it looks like to me I want to use tangent theta, because tangent theta uses opposite over adjacent. So instead of writing the theta symbol, I actually know what the angle measure is. So I'm going to write tangent of 78 equals the opposite side over the adjacent side. And then I'm going to solve that for x. So I'm going to multiply both sides by 7. I end up with 7 tangent of 78 degrees equals x. So when I go ahead and put that in my calculator, 7 times the tangent of 78 degrees is 32.9. So x is about 32.9. Okay, over here, last one. I'll just use the given angle. This is theta. 26 degrees is my theta. So this x is considered the adjacent side, and the 6 would be considered the opposite side. So when I write it out, I'm going to use tangent, because tangent uses opposite and adjacent. So tangent theta is opposite side 6 over adjacent side x. Got to solve that for x. So I'm going to multiply both sides by the x. Then I'm going to end up dividing by, whoops, I wanted to put, not tangent theta, I want to put tangent of 26. Let me rewrite that. So tangent of 26 equals the opposite over the adjacent, but I'm still going to multiply by x to solve. And then I'm going to have to divide by the tangent of 26. So x equals 6 divided by the tangent of 26 degrees. So x turns out to be 6 divided by the tangent of 26 degrees, and that's about 12.3. So that adjacent side turns out to be about 12.3. Okay, so just depending upon what the given side is, that's how you decide what trig function to use. Okay, we're going to move into a new topic now. So to do that, we've got a little bit of a kind of a little trial and error thing here to see if we can figure out some patterns. So first of all, it says find the length of the diagonal of the given square. So if it's a square, then all the sides are 8. If it's a square, then there's 4 right angles. The diagonal also bisects each of those angles. So this would be 45 degrees, and this would be 45 degrees. Well, if I were going to figure out what the diagonal is, I'm pretty sure I'd just go ahead and use the Pythagorean theorem, since it is a right triangle, and we're missing the hypotenuse. So let's go ahead and do the Pythagorean theorem. So 8 squared, so I'm trying to find the hypotenuse. So 8 squared plus 8 squared equals x squared. Well, that's going to be 64 plus 64, so that's 128. So x turns out to be the square root of 128. Well, if you break that down, that's just going to be 64 times 2, because we added two 64s together, right? So that turns out to be 8 square root of 2. So the hypotenuse here is 8 square root of 2, or the diagonal of that square is 8 square root of 2. Okay, we'll try it again with this other square. So once again, all the sides would have to be 6. Here's my right angle. Now I have a right triangle. This is 45 degrees here, 45 degrees up here. I can do the Pythagorean theorem. 6 squared plus 6 squared equals my hypotenuse. And that's going to turn out to be the square root of 72. And that breaks down to 36 times 2, since I had two 36s that I added together. So that turns out to be 6 root 2 equals the hypotenuse. So hopefully you're starting to see a pattern here that it wouldn't matter what my side is. I can always figure out what the diagonal is. So it looks like to me, if we just go by these two, and we could do a whole bunch of other examples, but if I draw my diagonal in, oh, let me do that again. So if we put our diagonal in right here, then here's my 90 degrees. This is 45, and this is 45. It looked like to me that the two sides were the same, and it didn't matter what they were, but the hypotenuse was always the side times the square root of 2. Okay, that's true. That's always true. This is one of our special triangles. It's called a 45-45. And it doesn't matter. I only need to know one side, and I know all three. Doesn't matter how big the triangle is, this pattern is always true. The hypotenuse is always the square root of 2 longer, or times that, times the leg. That's how it works. We just went through and proved that. We could do many more squares if you wanted, but that's always going to be true. The hypotenuse, or the diagonal of the square, is going to be the square root of 2 times each of those legs. Okay, so that's one of our special triangles. Okay, now we're going to do another one. It has to do with triangles. So this is an equilateral triangle. So it says find the altitude. So now an altitude is perpendicular. You go from one vertex perpendicular to the base. Now in an equilateral triangle, these sides are all 60, 60. Sides are all the same. But when you put an altitude in an equilateral triangle, not only does it bisect the angle at the top, so that 60 degrees now gets split into two 30s, but the base that it's perpendicular to is also bisected. So now this half is 5 and this half is 5. So if I want to figure out what the altitude is, I'm looking for x. Well, we have a right triangle here that we can use the Pythagorean theorem with. This is the right triangle that we're looking for right here. We just got to keep track of what's A, B, and C. So when I do the math on this, we'll say a squared is the 5, so 5 squared, plus b squared is the x, equals c squared, which is the hypotenuse. Okay, so when I go ahead and solve that, that's going to be x squared equals 10 squared minus 5 squared. So x is going to be the square root of 100 minus 25, so that's 75. And if you break that down to 25 times 3, that turns out to be 5 root 3. So this altitude right here is 5 root 3. Okay, take a minute, look at that, see if you can see any patterns developing. We'll try it again. So once again, this is a 30, 60, 90. So if this is 8, if I draw the altitude down here, oops, did I get that in the middle? Not quite, but if I draw that altitude, this side is normally 8, but since I'm drawing an altitude in, it's going to be it's going to be bisected, so it's going to be 4 and 4. And then this angle up here, so this is my 60 degrees, and this is my 30, and then this is my x. So I'll do the Pythagorean theorem again. So a squared, that'll be my 4, plus the b squared, which is my x, equals the hypotenuse squared. All right, so x squared is going to be 8 squared minus 4 squared. So x is going to be the square root of 64 minus 16, which is 48. And so that turns out to be 16 times 3, so that's going to be 4 root 3. So the altitude here is 4 root 3. Okay, so hopefully you can see the pattern here that's developing. Let's do that one. So here was a side, here was a side, and then there was the side. Down here, it looks like side, side, and then side. So if you look at this, it looks like to me, when I draw the altitude down, this is my 60 degrees, this is my 30 degrees. It looks like to me that the hypotenuse of this triangle right here and this side, they were always half each other, right? Because didn't we cut that in half when we did the altitude? So how I'm going to represent that, since they're always half each other, is I'm going to call this one 2x and this one x. So that's half. 2 is longer. The hypotenuse needs to be longer, so 2x and x. And then if you look close, it looks like to me that this side 4 gets multiplied by the square root of 3 to make 4 root 3. Up here, the 5 was multiplied by the square root of 3 to get 5 root 3. So then I think this side is always x times the square root of 3. And that's always true. This is our other triangle right here. This is called a 30, 60, 90 special triangle. That relationship is always true. The side opposite the 30 is always a half the hypotenuse. And the side opposite the 60 is always the square root of 3 times the shortest leg. Okay, so let's put those two formulas in. This you have to memorize. So in a 45-45, the two legs are the same. And then the hypotenuse is the length times the square root of 2. Okay, in the 30, 60, 90 special triangle, this is what I say. Remember, it's as simple as 1, 2, root 3. All you got to do is get those numbers in the right spot. So it turns out that 2 is the biggest number. 2 is bigger than square root of 3. So 2 has to go on the hypotenuse. 1 is definitely the smallest number, so it has to be on the shortest side. So it has to be across from the 30. Oops, not a 2x, got to be an x. And then the other side has to be the root 3 side. So this is x root 3. So if you know those sides, then you can figure out any of the triangles without all you have to have is one leg or one side, And you can find all the other measurements. You don't have to use the Pythagorean theorem. Sometimes you can't use the Pythagorean theorem unless you have, in the 30, 60, 90, you'd have to have two legs. 45, 45, you could do Pythagorean theorem still, but we kind of want to do this with the pattern. So, pattern looks like this. This side is x, x, and this is the x root 2 side. Well, if this side is 3, then the other side has to be 3. They have to match. And then I'm going to go from the 3 side to the hypotenuse side. I'm going bigger. This leg is shorter than the hypotenuse, so I'm moving to a side that is longer. So I'm going to have to multiply. Well, what are you going to have to multiply by? All you have to do is look at these two things. The only difference is the square root of 2. So I have to multiply it by the square root of 2. So this hypotenuse is 3 square root of 2. So 3 square root of 2. 3 square root of 2. Okay. Okay, let's try this one over here. That's a 30, 60, 90 special triangle. So remember our sides. This is the 2x side, x, and then x root 3. In the 30, 60, 90, I always try to find the shortest side first. Always try to find the shortest side first. So I'm going to go from 6 to the short side, which would be here. So how do you know what to do? Well, we already know that they're supposed to be half each other, but if you can't remember, this, as long as you get your x and your 2x in there, tells you the difference. This is 2x, this is x. I want to go smaller, so I'm going to divide. I'm going to divide by what number? 2. That's the only difference between the two sides. That's the ratio. It's a 2. So I divide by 2. So if this side is 6, then this side must be 3. Okay, now I want to go from the 3 side to here, to the medium side, I guess, if that's what you want to call it. Well, once again, I just look at how the ratios compare. I look at this x and that x root 3. The only difference is it's x root 3. Root 3 is the ratio. I'm going to a bigger side, so it would make sense to me then that I would multiply. So this would be 3 root 3. So I know that that's hypotenuse is 6, the short side's 3, and then the medium side is 3 root 3. All right, let's try it again. I know this is a 45, 45 because of the markings. That means these two sides are the same. You can leave square root of 8 the way it is, or you can write it as 2 root 2 and work with it like that. I think I'll just leave it as square root of 8. I'm going to try to go to a shorter side. Well, all I have to do is decide, first of all, am I going to multiply or divide? Well, since I'm going to a shorter side, I'm going to divide. What am I going to divide by? Well, looks like to me the difference in the ratios is a square root of 2. So I'm going to take square root of 8 and divide it by square root of 2. Well, square root of 8 divided by root 2 is the square root of 4, which is 2. So each of these sides is 2. Okay, here's a 30, 60, 90. I know this short side is 4. I'm going to put in my ratios so that I know this is x, this is the hypotenuse is the 2x side, and this is x root 3. All right, so I'm going to try to figure out where the other two sides are. So if I look here, if I'm going to go from 4 to this side, it looks like I'm getting bigger, so the operation I'm going to do is multiply. Well, what am I going to multiply by? Well, the only difference is the square root of 3. That's my ratio. So I'm going to take 4 and multiply it by square root of 3. So my answer is 4 root 3. Okay, then I'm going to look at the other two, and I'm going to do this side now. I'm going to go to the hypotenuse. So I'm going to go 4 to the hypotenuse. Once again, I'm getting bigger. By how much? Well, the only difference is the 2. It's twice as big. So if this side is 4, that side is 8. Okay, another 45, 45. This side is 2, so the other side is 2. Okay, I want to go to the hypotenuse. I want to get bigger. What do I need to multiply by? Square root of 2, well, this is x, this is x. The only ratio is root 2. So I need to take square root of 2 and multiply it by square root of 2, and you end up with 2. So my hypotenuse is 2. Over here, this is a 30, 60, 90. So this is my x side, this is my 2x side, and this is the x root 3 side. Okay, I want to go from 12 to the short side. It's smaller. You have to divide. Divide by what? Well, the only ratio difference is square root of 3. So I'm going to divide by square root of 3. 12 divided by square root of 3. Okay, well, I guess I'll rationalize that and see what happens. We end up with 12 root 3 over 3, and then those two reduce to be 4 root 3. Okay, so this side is now 4 root 3. Okay, now I want to go the hypotenuse. Well, it's bigger, so I'm going to multiply. What am I going to multiply by? 2. It's twice the length, so this is 8 root 3. Okay, these patterns just take practice. You just have to get it memorized on what are you going to multiply or divide by. If you're going from a short side to a longer side, multiply. If you're going from a longer side to a shorter side, divide. All you have to figure out is what's the ratio. And if you memorize your patterns, so if you memorize this, you'll know what to multiply and divide by.